Hello everyone, it's me again, and it's been a week since I updated my channel, and so today I figured I should throw something up there, make sure people don't think I'm dead or something. But to tell you the truth, it's been pretty hectic for the past week with assignments and homework, and I got sick the last couple of days, and I'm still really not feeling well. I actually went to the doctors today, and they told me I had some kind of virus infection in my throat area because my lymph nodes are all swollen up and stuff. So yeah, it's not good. It's not good at all. So I apologize if I sound kind of tired or just really crappy because yeah, I'm just really not feeling well. But I figure I should really kind of throw up a video, kind of tell people where I'm heading, and kind of give an overview of my next project on YouTube. So let's begin then. Like I said before in my previous videos, I'm going to do a series of tutorial videos on cloning, step-by-step cloning. And so today I want to give everyone an overview of what exactly those videos are going to contain, like kind of the stepwise table of contents kind of a deal. If you're not familiar with molecular cloning, then some of the stuff might not make sense to you. It's okay, don't worry about it, because in my tutorial videos, I'm going to go over every single step in extreme detail, and it's going to be crystal clear, hopefully, to anyone who's not familiar with laboratory cloning. So let's begin then. The first step we want to do when we begin a cloning project is that you want to design your primers, right? So this is extremely important. Please, this is very important, and please double check, triple check. Have someone else check it for you, because if your primers are not right, then everything downstream is just going to be completely ruined, and you might not figure that out for a while. So it's not good at all. So again, the first step is probably the most important step in this whole entire process. So second step, so once you have your correct primers, you want to amplify your target DNA that you want to clone into your vector, right? So you run the PCR, and then usually you take a small aliquot of your PCR product and run it onto like a 1% agarose gel, just to see if the band is there or not, to confirm, if it matches up with like the DNA standard of the correct size. So once you have a gel confirmation, a preliminary gel confirmation of your PCR product, you will take your PCR products, all of it, and then purify it through through like a PCR column purification kit. And many companies make those, like Invitrogen, Promega, Kaizen. So I'm pretty sure everyone has them in their laboratory. So no one really does it the old school way anymore. Thank goodness, because it's just so much faster and more accurate. So once you have your purified PCR DNA products, you want to restriction enzyme digest those products, right, according to your primers that you design. So this is important, because you want to make sure you cut them completely in order to have a better chance of them ligating on in a later on step to make your vector / insert construct. So once you digested them, you want to run your digestion product onto a gel again. This time you want to cut the band out from the gel in order to completely isolate the target that you want, and then run that through a gel purification column, and that is going to give you very highly purified DNA with the enzyme that that cuts at both ends. So you have highly purified DNA that's been correctly cut. Hopefully, that's what you're going for, kind of a deal. Something to be aware of: every time you purify DNA, whether it's through PCR or gel cut, you are losing a portion of your DNA. I'm not really sure exactly what percentage you're losing, but you are losing it, and it's not something minute either. I believe, I might be wrong on this, but it might be somewhere around 20 or 30%, maybe even more than that, of DNA that you're losing every time you're running it through a column. So just be aware of that. I'll talk about that later on too in my other videos. So after you have the your purified products, you want to ligate them now, right? So this is the step where you make your construct, your vector, and your amplicon, your insert. So you ligate it. Usually I do it at room temperature. overnight. Some people like to do it at 16 degrees C. I don't know. I have always done it at room temperature. It always worked. Again, I will go into this much more detail later on. So you ligate, and then of course, next step, you want to transform these into bacteria cells and play them out on a selective medium like ampicillin or kanamycin, depending on the cloning vector that you're using. Once you do that, you want to pick colonies that grew on those plates, and those might be right. So what you want to do is that you can run like a cracking gel on the colonies, or that's the quickest way, or you can like pick colonies, grow them up, and then digest them using the enzyme to see if you have the correct DNA profile after the cut. So once you have a couple of colonies that you've confirmed, you can grow them up more for DNA prepping. You can do like a media prep or a maxi prep. This really depends on what your other steps are going to be doing. Usually, I mean, if I'm going to be using it, I'll probably just do a media prep if I'm using it directly. But if I'm not going to be using it directly, or I'm not going to be needing a lot of it, I'll just do like a small mini prep, because there's no point of more than what I need. So once you have the preps, though, you want to completely make sure that it's correct. So you want to send it off to your sequencing facility and have that checked out to see indeed, okay, this is what my insert is. My insert is in there. It's the correct vector. Everything looks good. Yeah, so that's a very critical step. A lot of people skim over this step here, the sequencing, just based on like the gel, just a digestion cut profile. If they seem right, then they'll just go with it. Don't do that. Always sequence at these steps just to make sure what you're doing is correct. It'll save you a lot of time later on. Trust me, in case if something goes wrong. And after that, what you can do is just additional steps. It just kind of depends on what you're going to be doing. For example, my project that I recently, I'm finishing up now, I had to take that construct and then transform them again into other cells for like the whole back mineral combination thing. But at this point, you might be using your DNA for transfection. So it varies what you want to do with it, just depending on your project. I'm not sure how much additional steps I'm going to talk about in my videos. I might, for example, base everything on what I did for my PFAS back mineral constructions. So in that case, I'll probably talk more about back mineral combination and such. But yeah, that's kind of the overview of what my next couple of videos are heading. Hopefully start on them soon. Maybe this weekend will be good. But hopefully I feel better soon. It's just that, and this is really annoying, like my ear just feels extremely, it's not good. It's painful. So hopefully everything clears up soon so I can start on these videos. But yeah, thanks guys. Thanks for listening, and yeah, thanks for the subscribers recently. I mean, I know I don't really have a lot. There's only 3 of you guys, but thanks a lot for subscribing. Really, I appreciate it. And if anyone out there, if you're interested, go ahead and subscribe to me, and I will try to answer any questions that you send me or post up or whatever to the best of my ability. To help you guys out if you need help with some experiment that you're doing, or if you just want to talk to me about, stuff about, like grad school or whatever. But yeah, feel free to message me, anything is fine. So yeah, well, I guess I'll just see you guys next time then. Okay, I'm signing off.